brackets. Oh, don't put the 18 in front as well. How do you delete the 18? Right. Okay. So, recharged. We'll continue now. Okay. Guys, looking up? We'll continue now. Okay. So, second derivative, could nearly guess from the name what's involved here. Let's just, I don't know, x cubed plus x squared plus x plus 1. The first derivative would be 3x squared plus 2x plus 1. All the second derivative is differentiating again. So 6x plus 2. In other words, you have to use your rules twice. That's all that there is to the second derivative. You differentiate once, and then you differentiate a second time. So 2 applications of the rules. But now the question is, what is the meaning of the second derivative? So the first derivative, what does it represent on the graph? Do we remember? The slope of? Tangent, thank you. Slope of the tangent. No. No. The slope of the chord is this guy. Isn't it? And what's the slope of the tangent? Correct. Right. So, we have this situation. We know what y represents. Y represents the height. We know what dy dx represents. Dy dx represents slopes of tangents. But does anybody know what the second derivative represents? Nope. This is a case where, well, that's true, but what the heck does that mean? Oh, nice try. No. No. What is it? Don't say nature again, because you just said nature. No. So, what the second derivative tells us is what I would like to call the shape or the curvature, how curved the graph is. So, for example, your graph, maybe it could be curved quite radically like this, or maybe your graph might be just gently curving like this. The second derivative can tell us something about how it's curved. Okay. In fact, if the second derivative is a positive number, then I know that the graph will be curved like this. Whereas if it was a negative value, I know the graph will be curved this way, a sort of downward. Now these actually have names, these shapes, this type of curve. Yeah, but there's an adjective to describe which type of parabola it is, and they both begin with C. Which is which? You got a 50-50 chance. Which is which? The first one is, you're going with concave. 50-50, and you're wrong. It was convex. Yeah. And then the second one, therefore, must be concave. Yeah. Okay, so you'll need those words. Yeah. So the second derivative tells us the concavity, if it's concave or convex. Now you realize this is useful because if you know it's convex, then you also know you have a minimum. And if you know it's concave, then you also know you have a maximum. And in this way we can know the nature of the point, if it is a maximum or if it is a minimum. So can we go back to the cubic we did earlier where we had two answers? Okay. Can someone read out that cubic that gave two answers from the last lesson? What was it? 2x cubed. Yeah. Yeah. Right, so let's recapture the derivatives. The first derivative was 6x squared minus 6x minus 36. And then the second derivative will be 12x minus 6. Now, what were the two values for x? 3, and what was the y value? Or did we not get it? And what was the y value? Like this, yeah? So let's sub in this value, the 3 minus 51. And if you put 3 minus 51 in, you'll get 36 minus 6 is 30, which is a positive number. And if you put the minus 2 in, you'll get minus 24 minus 6 is minus 30, right? Which is obviously a negative number. So what shape is the graph here if it's a positive second derivative? We said convex. And what shape is the graph here if it's a negative second derivative? Concave. Now, if the graph is convex, then what type of point is this representing? Maximum. And this one here? Minimum. From knowing that it is this shape, and from knowing it's this shape, we cannot... Wait. Who said this? Minimum and maximum. Okay. If it's convex, it's a minimum. If it's concave, it's a maximum. Yeah? That's the next lesson. So, you're right. You've realized the potential problem here. What do you do in situations when the second derivative is 0? And that's a special case we'll have to look at in its own lesson. Yeah? Saddle point? Not necessarily. Not necessarily, which we'll see that in the next lesson. Are you looking for heat?
Yes, I'm looking for what if just this is some biofeedback essay plans.
Do you want
I don't want to distribute it, but the students will collect it on the way out.
Oh, okay, they have their names on it, is it?
Names on it.
Yeah, okay. So yeah, anyways, that gets its whole lesson in the next one. And Ray, you were saying, is it a saddle point? Not necessarily. There are situations where the second derivative is 0 and it could still be a max or a min. But still, we need to address that for today's lesson. So for this lesson, what we'll say is, if the second derivative is positive, that means we have a min. If the second derivative is negative, that means we have a max. And if the second derivative is 0, it doesn't mean we don't have a max or we don't have a min, or we might have a max or we might have a min. We'll say that the test is inconclusive, meaning we just don't know. That's not the same thing as saying it's not max and not min, or it is max and is min. We're saying we don't know. So we'll have to do some other calculation to know if it's max or min. Okay? So for example, you could make the graph, and you could judge from the graph if you have a max or a min. I'll do another example. I want to do that log example I gave you in a moment. Okay. We got that? Yeah? Actually, before we do the log example, I want to do something else with this cubic here. So I just, very rough sketch, I don't remember. You have the sketch from earlier maybe. Well, it was something like this, wasn't it? Something like this, yeah. So far we found 2 points. We found the maximum and the minimum. But there's another interesting point in the middle here. Now, this point here is interesting because if you look at it, what is happening is to the left of this point, the graph is concave. But to the right of this point, the graph is convex. Whereas something happened here where it switched between being concave to being convex and vice versa. And this is an interesting point. And this point has a name. Does anyone know it? This one is called an inflection point. And these are important points on graphs, where graphs transition from being concave to convex. Now, you sometimes get these in biology. You know, you have some kind of process where initially maybe the graph is concave, then something happens and then it switches to being convex. You know, you get these in biology. I can't think of an example off the top of my head. Colin would know graphs that have inflection points where they switch from being one to the other. So, if you look here to the left, the second derivative is positive, and to the right, the second derivative here is no, did I say that right? Sorry. To the left here, the second derivative is negative, and here to the right, the second derivative is positive. And so what is happening here? The second derivative we think might be 0. Now, before you jump the gun and say, wait, hold up a second, Stephen. 1 minute ago you said we don't know what's happening when the second derivative is 0, right? And now I'm just telling you the second derivative is an inflection point. Is that a contradiction? No, because there's something else here. This inflection point needs the second derivative to be 0, but it also, very importantly, needs the first derivative to not be 0. And that's different to what we had earlier. Earlier we had the first derivative is 0 and the second derivative is 0. And that's a difficult situation. We don't know what's happening. But in these situations where the second derivative is 0 and the first derivative is not 0, we have an inflection point. In fact, for this graph, the first derivative at that inflection point, will it be positive or will it be negative? You can tell from the graph. What will it be? At the inflection point, what is the first derivative doing? What value will it be? Negative. Why? Yes, because it's decreasing. And what is the slope of a tangent if it's decreasing? If it's pointing down, it is negative. So, let us find the inflection point for this cubic. It's pretty clear. This is the second derivative. The second derivative equal to 0, so what does x equal? 1 over 2. So at the point a half, we have an inflection point. The graph switches from being concave to being convex. Yeah? We'll do more examples, don't worry. Right. Let us do the log example, and let us find out if the points are max or min. So, can someone give me the log example we had earlier? The last log example we did. Y equals log x 16. Minus 3. Now, we got the dy dx earlier. It was 16 over x minus 2x minus 14. And if we get the derivative again, this will be minus 16 over x squared by using the fact it's x power minus 1. And this one here is, what's next? 2. Yeah. Okay. What was our first x value? It was something like 1, wasn't it? So if I put x equals 1 into this, I don't even have to calculate it. It's obviously going to give me a negative number. It'll be minus 18, won't it? And what was my second x value? Minus 8. So that will be minus 16 over 64 minus 2. That's also a negative. So what type of points do we have here? We have 2 maximums, don't we? It's concave at both points. Yeah? Yeah? Yeah, we saw the graph earlier. Do you remember it? It's like the McDonald's sign. It went like this. It had 2... Yeah. Yeah? Now, you could try to figure out, is there anywhere where this graph will be convex? Let's see. Let's ask the question, where will it be convex? We'd like to know, where will this graph be convex? How might we figure that out? Yeah, what is it? Not dy dx less than 0, but the second derivative less than 0. Yeah, or we could try and find an inflection point. But I like the inequality. We want to know, convex means this shape, which means the second derivative is positive or negative? Positive. Positive. Confused me. The second derivative, is it positive? Let's figure out, can we find such a point? So what will I do first? I'll take this over. And I get this. Okay, and then maybe I could multiply across. And I get this. What should I do next? And what will it become? X squared less than minus 8. Now you realise we have a situation where we cannot find an x that can do this job.
Why?
Yeah, why?
Because square is minus.
When you square the x, you get a positive, which can certainly never be less than minus 8.
The domains, it can't be there also.
Say again?
The domain.
Yeah, what about the domain?
It can't be there. It's logs now.
And you also can't have x as 0, yeah, but it's worse than that. You can't have a positive being smaller than a negative. So this answers the question quite clearly. Where will it be convex? The answer is never. I can never find anywhere on this graph where the second derivative is going to make this convex. Okay, what about another question? Where will this graph be increasing? So I want to know the parts of the graph where it's increasing. So that should be here, it's increasing, and here is increasing. Whereas there and there it's decreasing. How can I find that?
From minus infinity till turning point.
Yeah, so let's just pretend I didn't have the turning point. If I wanted to make it as an inequality, what would I say?
So we put like brackets.
Yeah?
Then we'll have to like find the point where.
Yeah?
Yes.
Yeah, but without finding the turning point, by making just one equation.
By using the
First derivative. What about it? If I want it to be increasing. More than 0. If I can solve this, I found where the x will make it more than 0, which means where it will be increasing. Now that will correspond to what you said about the turning points. No, don't doubt yourself, man. You were right the first time, more than 0. Okay, so what should I do to solve this? Multiply by x, right? Although there's a small problem if I do that. What's my small problem if I try to multiply by x? Ah, no. Why can't I multiply by x? Come on, guys, listen. Hey. That's it, yeah. You don't know if x is positive or negative. And if it's negative, what happens? The sign changes. Anyways, there's an easy way to fix that. What we'll do is we'll break the problem up into two halves. We'll look at first only positive x's, and then secondly negative x's. So if x is positive, can I multiply by x? Yeah. And do I have to worry about the sign? No. So that will be 16 minus 2x squared minus 14x more than 0. That's 2x squared plus 14x minus 16 more than 0. That's x squared plus 7x minus 8 more than 0. What are the two solutions here? 8 and 1, isn't it? 8 and x minus 1. So do you remember how to do these? It's like this. Minus 8 and 1. Do we want above or below? Above? Above? Which is here. Why do I not include this part of the answer? Yeah. So x more than 1. Well, how do I know if I'm right? Remember the turning points we found earlier. Was one of them 1? Was it? Is this wrong? Is this right? Do I still have the graph? Let's see. No. We'll make the graph. We'll make the graph again. Right, what's confusing here? Did I make a mistake? That would be the first thing. Is there any step that's wrong? No? So why do you look confused? Just letting it in, accepting it, yeah. It's positive, because it's positive x squared, and it's more than 0. Well, I'm not sure what you're asking me, actually.
Minus 2x squared.
Ah, we did, didn't we? Yeah. But then, oh, sorry, thank you. Thank you for, so I did make a mistake, you liars. I took everything to the right. You're right, so this sign is the wrong way around. Thank you. See, for being sleepy in class, you're the only one that's actually awake, which is concerning, because it's making me think, how sleepy are these guys then? This should be less than 0. So now it's different. It should be below. Yeah, which now is here. How far do I go? Yeah, to the line. Why can't I go past this?
Oh, because it's more than 0. Yes. Now I get it.
It's only Monday, please. All right, so what's the answer here? Thank you. X less than 1, but also more than 0. Okay, you sound satisfied with this now. Good. Right, let's look here. So x is negative. If I multiply through by x, what will happen? Well, I'll get 16 over x. Oh. Sorry, one sec. More coffee. Right, I get 16 minus 2x squared minus 14x. But what's a little bit different now? Switch y. Negative. So it's like this, isn't it?
Yep.
Taking everything to the right, I'll get 2x squared plus 14x minus 16 is... Now be careful. I forgot to change this. Flip it around. And then taking everything to the other side, means it is like this now. So it's the same picture except we're looking at different points. More than 0 is here or here. Which one do I take, the left or the right? Which one do I take, the left or the right?
Left.
Because?
Less than 0.
Yes, thank you. So what's the answer here? X must be
More than minus. No. Less than minus 8.
less than
Minus 8.
-8. And do I need to say anything else about it being less than 0?
No.
No,
Why not?
because
Infinity.
It's already less than 0 if it's less than 8. So, to put these two answers together, we're saying that the function is increasing between 0 and 1, and it's increasing if it's less than -8. Yes? Let's check the graph to see if that works. What was the function, please? Y equals log x power 16. Yep. Okay. How far do I need to go? -8, isn't it? And then, what's the biggest number? 100, wasn't it? Right, let's check this out. Actually, let's go a bit further. The graph is increasing between 0 and 1. Let's see if we agree. Is it increasing between 0 and 1? Yeah, and then what happens after 1? Decreases. Is the graph increasing if x is less than -8?
Yes.
All the way here it's increasing until we get to -8. And then what happens? Then it begins to decrease. Okay. So it although a bit inconvenient, it did work. Now your way of doing it with finding the turning points also works too. It depends on the question. So you see, in the exam, if part A was to get the turning points, part B to determine if they're max or min, then yeah, part C you could use the previous answers to know where it's increasing. Okay? But if the question was just where is it increasing, and they didn't ask you to get the turning points first and to determine if they're max or min, then you have to do it this way. Okay? If you knew, for example, if you knew this turning point and this turning point, and you knew that this was a max and you knew that this was a min, then you can know to the left of this answer is increasing, and to the right of the minimum answer is increasing. It can't be decreasing, because then it's not a min. So you can do it that way if part A was to get the turning points and part B was to work out if they're max or min. Then part C can give you it quite easily.
yeah, and what would we have like local max and local max?
Usually the exam, they only care about local. You don't have to worry if it's global or not. So in the exam, whenever they say max or min, really what they're saying is local max and min, but they don't always put the word local in there. Okay. Now, to finish this, just to put this all together, at the bottom of your worksheet, there's a table here that I left blank for us to fill in. Can you see that table at the bottom? Mm-hmm. Yeah. So what we're going to do, I mean, you don't have to put this in the workbook. You can copy it into your notebook if you want. But I just thought being in the workbook might be a little easier for you. We're going to draw all the different shapes for those 9 situations, okay? Can you see that? So the first situation, the first derivative, what is it doing? The first box. First derivative is what? Positive or negative? Negative. And the second derivative? Negative. So let's think about this. First derivative is negative. So what does that tell us about the graph? What's it doing? The slope is negative. So what does that mean? It's downward. Downward. Now wait, the second derivative now. The second derivative is negative. So what does that tell us? It's concave. So we need to think about this. We need to draw a graph that's going down. It's downward trend, but it's concave. So that would be something that's like this shape. That's concave, isn't it? And is it going down? It is. Okay. So in situations where both are negative, you're looking at a graph that's shaped like this. Okay? So please add that graph into your first box, and then we'll go on to the next one. Okay, next. The first derivative is 0. So what do I have there? What type of point is that? Maximum or minimum. But the second derivative is negative, which makes it concave shape. It's the tip, yeah. So the second situation is this point here. Yeah. Okay, continue. The next one. The first derivative is positive, but the second derivative is negative. It's increasing and it's concave. So the only way I can draw increasing and concave is some graph that maybe looks like this. Yeah? Oh, sorry. Disgraceful. Like this. Concave and increasing. Okay. On to the next one. The second derivative is 0 and the first derivative is negative. So first derivative is negative. What's that doing? Going downward slope, yeah. And the second derivative is 0? I know you do. It's an inflection point. So if it's going downwards but it's an inflection point, then it's probably that you were originally at a maximum and then going into a minimum. Yeah. Well, actually, no, I don't need to dot it. It's this point here is what we have. Whoops. If the first derivative is negative, but the second derivative is 0, we have this point here, this downward inflection point. It has to be max to min, right? I can't draw this going min to max inflection point. Yeah, like I could try. There's a min. No, you see, because if I do it like this, then it's a positive. Yeah, it says can't. It has to be this. It can't be done. I don't think. Right. Next one. The first derivative is 0 and the second derivative is 0. What do we have? Dasha, get off the phone. First derivative is 0 and the second derivative is 0. No, Dasha, put the phone out of your hand. No, later. What are you taking a picture of? Okay. Sorry, I got first derivative is 0 and second derivative is 0. What do we have?
The slope of the inflection point is 0.
Yes, what shape do we have? An S, like this, is it?
No.
What do we have? Stairs, is it? This? A H. What do we have? No idea. You don't know. if the first and second derivative are both 0, you don't know what you have. Now, I'll give you an example to show you why you don't know what you have. So, let's take an example here. X power 4. I want to know what shape I have when x is 0. Okay, so when x is 0, y is 0, fine. Whoops, sorry. Derivative, what's the derivative here?
3x.
It's 4x cubed. When x is 0, what do I get here? 0. And if I differentiate again, what do I get? 12x squared. When x is 0, what do I get? So the first derivative is 0 and the second derivative is 0. If I graph this, I have this shape, which is a minimum. Okay, let's look at something like this. X power 5. What's the first derivative? It's 5x power 4. When x is 0, what do I get? 0 again. And you see what's happening here. The second derivative will also be 0. But what shape do I have here? I have a totally different shape. Okay, this is my point. My point is when the first and second derivatives are both 0, you actually don't know anything about the shape. It could be anything. Okay? So you literally have no idea. You've no idea what shape, what situation you have. Can't tell. Can't tell. Could still be anything. Okay, next one.
So is the answer like, I don't know.
Yeah, you can't do that in the exam. In the next lesson, we'll discover what to do. Okay, next one. The first derivative is positive, but the second derivative is 0. So what do we have here? It's increasing inflection point, isn't it? So,
Minimum to maximum.
yeah, minimum to maximum. It's this point here. Okay, next one. Downward and second derivative is positive is concave, isn't it? Don't confuse me, hang on. Second derivative is positive, which is convex, thank you. Isn't it?
Yeah.
Okay. So convex and decreasing looks like this. Yeah. The next one is convex and a turning point. So what's that? Convex and a turning point has you where? At a minimum, yeah. So the next one is this. And lastly, it's convex and a positive first derivative. So that's convex and increasing, which is going to look like this. Convex and increasing. You got all those 9? Yeah. So the only one that we don't know what's happening is the middle one, 0, 0. And that's actually going to be in a later lesson. Yeah. You need to be having this knowledge in your head. Yeah. Yeah. But for me, it's easier to remember, you know, convex, concave, or increasing, decreasing. And let me give you some questions to try now for a few minutes. Okay. 2 B C F and 3 A B. Oh, and I'll give you 1 F. Okay. 1, 2, 3, 4, 5, 6 questions there.
1F?
Yeah. Question 1, letter F. Why is this shocking? Okay, get a start on those. No, give me 1 minute. Just give me 1 minute, please.